Hi everyone, welcome to TACoS Computer Science Day 5. Today, we're going to spend the whole time making our very own snake game. So what you're going to need is your microbit, the cable, your joystick bit, and you should still have those batteries in the back. Let's get going. Today, we're going to use the microbit, joystick bit, and everything we've covered this week to make a simple snake game. Our game is going to be a simpler version of the snake game that you may have played before. You'll move your snake around the microbit screen and eat bits to increase your score. The game will move a little faster every time you eat a bit, and if you run into a wall, it's game over. In our version of the snake game, one unit of time will be represented by one pass through a loop. A pass through a loop is called an iteration. So, in each iteration of our game's loop, we need to do the following basic things. Move our character in the correct direction, check if we've hit a wall, and check if we ate a bit. We'll have to keep these things in mind while we create our game. We'll make our snake game in 6 steps. First, we'll create our snake and our bit. In step 2, we'll set up the loop and move our snake. Step 3 will be about eating and moving the bit. In step 4, we'll end the game when the player hits a wall. In step 5, we'll increase the difficulty of our game. And in step 6, our final step, we'll add a pause and resume function. Step 1. First, let's create our snake and our bit. To get started, we're going to have to create a new project in MakeCode. Since we'll be using the joystick bit, we need to follow the same steps from yesterday. So go ahead and scroll down and add the joystick bit extension. Once that loads, go into the joystick bit tab and grab the initialization joystick bit block and put that in your onStart block. Next, let's get our sprites created. We'll start with the snake sprite. Similar to what we did yesterday, we'll create a new variable called snake. Then, in the onStart block, we'll set our snake to, and then go into the game tab and grab that create sprite at X, Y block. Now we want to display a bit somewhere random on the screen for our snake to eat. Let's represent the bit with another sprite. Create another new variable called bit and drag a set bit to 0 block into the onStart block. We also need to set its value using the create sprite block, but this time we want it to appear at a random location instead of right where we put our snake. We can give it a random location by using a random number block from the math tab. Go ahead and plug 2 of those blocks into the create sprite block. Now, since the only valid values for x and y are 0 through 4, let's change the 10 in each pick random block to 4. Since our snake sprite and our bit sprite look exactly the same, it'll be really hard to tell which one is which. Let's fix that by lowering the brightness on the bit sprite. Go into the game tab and find the set x to 0 block. We want to change the brightness of bit, so I'll change this variable first, and then set brightness instead of x to 15. This is a good spot to stop and make sure that your code matches mine before we move on to step 2. Step 2. Setting up the loop and moving the snake. We'll start by recreating the same if-else-if structure that we used while working with the joystick yesterday. Your code should look like this. It should say, if rocker value of x is greater than or equal to 900, else if rocker value of x is less than 100, else if rocker value of y is greater than or equal to 900, else if rocker value of y is less than 100. Now for the changes. Yesterday, we moved the sprite across the x and y axes using the sprite change x by 1 and sprite change y by 1 blocks. Today, we'll do things a bit differently. we're going to use the joystick to give the sprite a direction, and then we'll move the sprite in that direction. In order to do that, we'll use the sprite set direction to 0 block. This block is the same as the sprite change x by 1 block in the game tab, so go ahead and drag that out into your work area, and then change the x dropdown to direction. You'll also want to change the sprite dropdown to say snake. Let's put one of those blocks inside each of our if and else if blocks, just like this. Go ahead and pause here if you need to, so that you can get all of those blocks set up correctly. Now we have to figure out the correct values to put within our set direction blocks. The number this block is expecting is a degree value. If you've ever looked at a compass, the directions around the compass are represented as degrees. Each direction on the compass is represented by a degree value. North is 0 degrees, east is 90 degrees, south is 180, and west is 270 degrees. The value that the set direction block on our microbit wants is also a degree value. Let's see what the degrees on a compass look like in relation to our microbit. Now we know what values to give the set direction block. Up is 0 degrees, right is 90, down 180, and left is 270. Let's go fill in our set direction blocks with the correct values. In the top block, we're checking if rocker value of x is greater than or equal to 900. A rocker value of x being over 900 means the joystick is pointing left, so let's fill in the correct degree value for left, which is 270. Go ahead and pause here so that you can fill in the correct values for the other 3 possible directions the joystick could be facing. When you're finished, come back and we'll double check your work. Welcome back! Let's double check your answers. The first block is pointing left, so we should set that direction to 270. When the rocker value of x is less than 100, that means it's pointing right, and so the direction should be set to 90. A rocker value of y that's greater than 900 is pointing up, so that direction should be 0. And a rocker value of y that's less than 100 is pointing down, and that direction should be 180. Now that we can change the snake's direction using the joystick, all that's left is to get it moving. This step is super easy. All you have to do is go into the Game tab and grab a sprite move by 1 block and put that at the bottom of your if statement. Then be sure to change that sprite to the snake. One last step here. The microbit can run the loop much faster than a human can react, so let's slow that loop down a little bit. Let's go into the Basic tab and grab a pause block and place that below our snake move by 1 block. Then change the pause from 100 milliseconds to 1000 milliseconds, which is the same as 1 second. This is a great point to pause and make sure that all of your code is set up the same way that mine is. When you're finished with that, you should be able to control the snake using your joystick. Go ahead and test it out by downloading the program onto your microbit and make sure it works the way you expect it to. Step 3. Eating and moving the bit. After the snake moves to a new spot, we need to check whether or not we're on top of a bit. What programming element do you think we can use to check whether or not something is true? I'm talking about an if statement, of course. In this case, we can check if the x and the y values of the snake are the same as the x and the y values of the bit. If they are, that must mean that the snake is on top of the bit and he can eat it. So, we're going to want an if statement that looks like this. If the x value of the snake equals the x value of the bit, and the y value of the snake equals the y value of the bit, then eat the bit. We'll add this if block after the snake move by 1 block, but before the pause block. Try setting up the conditional statement in the if block by yourself. You can get the x and y values of the snake and bit from the Game tab by using this sprite x block. Just be sure to change the sprite dropdown to snake or bit, and change the x to x or y when necessary. Go ahead and pause here so that you can see the if statement that you're working with. Do your best and then come back to check your answers. Welcome back. Hopefully you came up with something that looks kind of like this. It should say, if snake x equals bit x and snake y equals bit y. Now, how do we eat the bit? All we need to do in our shiny new if block is increase the score by 1 and then move the bit to a random new spot on the screen. There are two ways to increase the score. The first one is to use a change score by 1 block. This way is pretty simple, but it causes an animation to flash on the screen and you can't see the game. Instead, we'll use the set score 0 block. Instead of setting the score to 0, we want to set the score to score plus 1. So we'll get the addition block from the Math tab and replace the left side with the value of score, which you can get from the Game tab. The final result should read set score to score plus 1. Now we'll grab two sprite set x to 0 blocks out of the Game tab. The sprite that we're wanting to manipulate is the bit, so go ahead and change that in the drop-down. And then grab two pick random 0 to 4 blocks from the Math tab. Be sure to change the range from 0 to 4. Then we'll need to change one of those to set y. This will move our bit somewhere else on the screen now that it has been eaten by the snake. Once you've got all those blocks in the right place, let's take a moment to check our work and test our code. Right now, your code should look similar to this. I'm going to scroll down so that you can see the full forever block. We haven't changed the onStart block in a while, so that should be fine. This would be a great time to stop and make sure that your code is correct, because at this point, we almost have a working game. Why don't we test it out? Go ahead and download your program to the microbit and make sure you can move the snake around and eat the bits. Every time you move the snake over a bit, the bit should move to a new location. And even though we don't have a way to see our score should also be increasing each time we eat a bit as well. Step 4. Hitting a wall. Our game is already pretty awesome, but it has no ending. In the traditional snake game, the game ends once you hit a wall. Let's add some more blocks to our program that end the game once the snake hits the wall. Checking whether or not we've hit a wall is a little bit tricky. The snake moved by 1 block won't let our snake go out of bounds. So the x and the y values of the snake can never go below 0 or above 4. We can't use those values to check if we've gone out of bounds. The snake moved by 1 block doesn't do anything if it would put the snake out of bounds. Instead, after we know which direction the snake is facing, but before it tries to move, we need to check if a move in that direction would make the snake hit the wall. If you're already thinking we need another if-else-if block, then you're definitely right. After our first if-else-if block, but before our snake moved by 1 block, we need another if-else-if block. Our new if block needs 4 conditional statements. The conditional statements need to handle 4 different situations. The snake is facing down and is at the bottom of the screen. The snake is facing up and is at the top of the screen. The snake is facing right and is at the far right of the screen. And the snake is facing left and is at the far left of the screen. In each of these cases, the next move would make the snake hit the wall, so it's game over. Go ahead and try to set up each of the 4 conditional statements to match the 4 conditions that we listed. But before you get started, let me give you a couple hints. First, you're going to need an AND block out of the Logic tab. And inside that, you'll need an equals block. Then, you can get the degree value of the direction the snake is facing by using a sprite X block out of the Game tab. You'll have to change the sprite to snake, and change x to direction. Here's an example so that you can use that as you're working through. And also, here's a microbit with its degrees labeled. There's one more important thing that I need to tell you before you get started. When you set sprites to face left, you give it the value 270. However, when you read the direction of that sprite, the number reported will actually be -90 instead of 270. Here are a couple more hints. Go ahead and pause here and check back in when you're finished. When you're all finished, it should look something like this. Make sure that snake direction equals 180 is paired with snake y equals 4. Snake direction equals 0 should be with snake y equals 0. Snake direction equals 90 goes with snake x equals 4. And snake direction equals -90 instead of 270 goes with snake x equals 0. Now that we've got these conditions set, we need to put something in them. Conveniently, the Game tab gives us a Game Over block, so we'll put one of those after each of our conditional statements. All you need to do is go into the Game tab and find the Game Over block, then drag one Game Over block into each of your if statements. Now, let's test out our newly placed blocks. Go ahead and download the program to your microbit and see how it works. At this point, the code is getting a little bit too long for me to show on my screen all at once. So if you find that your code isn't working and your microbit isn't acting the way that you're expecting it to, head to our website and go into day 5. Then if you scroll down to step 4, which is the step we're on right now, you can find a solution to where we're at right here. At this point, our game could be complete, but I think we should add a couple extra features to make it even better. One thing you might notice while you're playing your game is that after you practice for a little bit, you could probably play it for a really long time without ever hitting a wall. Let's make things a little more interesting by speeding up the game a little every time you eat a bit. To do that, we'll start by creating a delay variable. Go into the Variables tab and create a new variable called delay. Then set delay to 1000 in the onStart block. Next, we'll replace our pause value with our delay variable. Go down to the end of your forever block, and where we've got that pause, replace the millisecond time with your delay variable. Now, the result should pretty much be the same, since delay is equal to 1000. Setting pause to delay still gives us the same speed. The next thing we'll do is decrease the delay a little every time the snake eats a bit. Somewhere inside the if block that checks if we're on top of a bit, we need to add a change delay by 1 block. Inside this block, we'll replace the 1 with a -50. Now, each time we eat a bit, the delay between each iteration of the loop will decrease by 50 milliseconds. Go ahead and download and test your new code. You should notice that after eating bits, your snake moves faster and faster. Step 6. Adding pause and resume. The last feature we'll add to our game is the ability to pause it. Let's use one of the 4 buttons on the gamepad to pause our game. Drag an on button C is pressed block from the joystick bit tab into your working area. You can change from using C to using whatever button you'd like, but we'll use D in our example. The Game tab has several blocks related to pausing and resuming the game. One of them is the angled is paused block. Angled blocks are always either true or false. In this case, is paused is true if the game is paused, and false if the game is not paused. We can use this block inside an if-else conditional statement to enable one button to do both the pausing and the resuming. Add an if-else block into your on button pressed block. Then use is paused from the Game tab as your conditional statement. Now, we want to use the pause block to pause the game if it isn't paused, and the resume block to resume the game if it is paused. To find these blocks, you'll have to click on this More tab below the Game tab, and they're right there. Go ahead and drag these blocks into the correct places inside our if-else block. Now, we should be able to use a gamepad button to pause and resume the game. We only have one problem. The pause block only pauses the sprites being displayed on the screen. It doesn't pause our blocks in the forever block from running. Luckily, there's an easy fix for that. We're going to put all of our blocks that are currently in the forever block into a big if block. Grab an if block from the logic tab, and then if you hover it just right in your forever block, it'll grab everything. Now, the conditional statement for this new if block should be not is paused. We can do that by grabbing a not block from the logic tab, and then putting another is paused block inside of that. Now we have an if block that means if the game is not paused, then run our blocks. That leaves us with just one thing left to do, which is to download and test your final code. Congratulations! We created a simple version of the classic Snake game. If you need it, you can view a final example of the code on our website to check your work. You might have noticed that our snake doesn't grow a tail as it eats bits. It turns out growing the snake's tail is a pretty difficult thing to program, and it requires using a lot of blocks that we haven't covered this week. As you use your microbit more and program other things, think about how you could add that functionality and implement it in your code. In order to make our snake game, we had to use all the things we've learned throughout the week. We used inputs and outputs to control the snake and see the game on the screen. We used variables to store the two sprites, the snake and the bit, and to store the delay between each iteration of our loop. We used if-else blocks to change the direction of the snake, see if the snake hit a wall, and to pause and resume our game. We used one big loop, the forever block, to drive the game. And we used our joystick bit to tell the game which direction we want the snake to go, as well as a button to pause and resume the game. We also learned one extra thing today, and that was how to use degree values to represent directions. Thanks for joining us this week. There's still so much more that you can do with your microbit and joystick bit. Head over to the MakeCode website to try out some of their tutorials and come up with your own ideas for games and other cool things that you can do with your microbit.